Hi everyone, welcome to my YouTube channel Take Data Engineer. So in this video we will see what is Delta Lake and what is Hudi. Okay, so why we are using that and why we are bringing this to our project to enhance the storage capabilities. Okay, so first we will understand with the Delta Lake their properties, what is why we are using this in case of time travel, schema enforcement, or any upsort delete actions. Okay, so what is the use of Apache, this one Delta Lake and Hudi. Okay, so first we'll start with Delta Lake. So Delta Lake is nothing but like open source a storage layer. Okay, so this is basically a storage layer that brings the AC transactions, a schema enforcement, time travel, and streaming support to big data workload in Apache Spark. Okay, so this is not the Delta Lake is nothing but it is the open source storage layer that brings the like properties like AC transactions, schema enforcement, time travel, and streaming support to big data workload. So Delta Lake is basically created by Databricks, and it is basically built on Parquet file. Okay, and it maintain a delta log. So delta log is basically whenever there is a transaction happen on that particular file, it will maintain a delta log for that. Okay, based on that only it will go to previous timestamp or time travel, and it will fetch the data. So the benefit of using delta lake is it is basically managing a transactions log called delta log. Okay, and you can integrate it with PySpark application. So whenever you have a PySpark code, you can seamlessly you can integrate that also. Okay, so how basically Delta Lake works, we will see. So data is stored as a Parquet file. So in case of Delta Lake, we store data in the Parquet file. A transactions log is nothing but it's a delta log. Okay, so delta log is nothing but it's like a track of all the changes whenever there is a append, update, or delete happen to your file. It will maintain a log. Okay, based on the transactions or whenever there is a commit happen, so it will maintain changes. Okay, and it will store in a delta log. So based on that delta log only, it will check the time, it will try and go and check the previous time, and it will fetch the data based on the timetable. And each write creates a new version of table. So whenever there is a new write happen to the table, it will create a new version. Okay, so Spark read from the latest snapshot using the transactional log. So whenever there is a read happened, it will uh, it will take the latest transactions and do the read. Okay, so what is the basic delta table structure? So delta table structure, like suppose there is a customer file we have this is like a part snapshot parquet, this one, and it will maintain the delta log. Delta log is nothing but it's like metadata, like whenever there is a add happen, update happen, or remove a file happen, it will maintain a transactions. Okay, and then there is a checkpointer parquet happen. Okay, so there is this is basically nothing but it's like a delta table. It's managing a metadata. So whenever there is a upsert, delete, remove happen to the file, it will mention a metadata, like when this transaction happen. Okay, so this is basically delta lake. Delta lake brings the AC transaction schema enforcement timetable and stripping support to big data workload. Okay, and how it works basically, it is based on built on the Parquet file and maintain a delta log that is called a transaction log. Okay, now coming to the Apache Hudi. So Apache Hudi is nothing but like Hadoop support. It's like upsert, delete, and incremental. It's like a data lake framework. So it is also similar to the Delta Lake, but it is named as Apache Hudi. Okay, this is also work for streaming ingestions, incremental poll, that is called incremental watermark data, or upsert and delete at scale. Okay, so Apache Delta Lake was created by Databricks and Hudi was created by Word. Okay, so this is also used for optimizing the real-time ingestion pipeline. Okay, and how Hudi work? So Hudi track a timeline of action. So when there is a commit happen or cleanup happen or rollback happen, it will maintain, it will track, it will store the timeline of actions. Okay, and this is basically, this uses the Avro schema to manage evaluations. Okay, so how delta table uses basically Parquet file, this is using the Avro. Okay, Avro schema, and can store data in COW and MOR mode. Okay, manage of read, merge of read and copy on write. Okay, that is also works on basically Spark, Flink, Presto, Trinio, and Hive. Okay, so this basically work with this many tools. Okay, so there are types of tools in two types of tables in Hudi. Okay, new Parquet file written on each update. So whenever there is each update happen, we'll maintain the new Parquet file that is called copy on write. Okay, okay, and merge on read. So update read retain as delta log and merge at each read time. Okay, so when there is a MR happen, it will do the update the retain delta log and merge at the time of read. Okay, so these two types of table it maintain basically. Okay, now we will see the comparison feature. Okay, when to use Delta Lake and Apache Hadoop and Apache Hudi, and what are their basically features. Okay, so if you talk about the acid property like atomicity, consistency, isolation, durability, so if we talk about the acid transaction, it will provided by both Delta Lake and Apache Hudi. So how Delta Lake manage based on the their Delta log table. Okay, and this is basically managed by timeline plus metadata. It maintains both. Okay, so timetable is supported by both, schema evaluation is supported by both. So this is basically uses merge schema, and this is average schema. Okay, merge upsort support, this is merge and supported by both. Okay, SQL style merge into a native upsort operations. Incremental query is not, so this is not supported by Delta Lake, but it is there in the Apache Hudi. Streaming support, yeah, structural streaming, it is supporting, it's a Delta stream or a Spark streaming is supported by Apache Hudi. So format Parquet plus Delta log, Parquet plus Abro plus metadata. Okay, read write engine, Spark only based for Databricks, and Spark, Hive, Flink, Trino, Presto. So this is using all these thing engines. Okay, performance for a small file can be slow without file compaction, and this is built in small file compactions. Okay, so these are the features we have. Now if you talk about the use cases, so this is use cases, which types of use cases Delta table lake fix, like whenever there is a Delta lake plus ML pipeline, then we'll go with the Delta lake. If there is a real-time ingestions and change data capture supports are there, or lake house are there, then we'll go with the Apache Hudi. Okay, so this is basically by Databricks Microsoft, this is over Amazon open source contributions all. Okay, Apache Hudi. Okay, so this is also like if there is a batch plus a streaming hybrid, ML or AI pipeline, time table and historical data query, or we wanted like seamless experience with the Databricks, not Databricks, no, we'll go with the Delta Lake. If there is a real time with the Kafka or Flink, or change data capture from OLTP system, or there is incremental update or partial load happen, or any massive write or heavy pipeline like IoT, mobile apps, or any server capture, these types of scenarios are happen, we'll go with the Hudi. Hudi is great fit for that. Okay, let us understand a simple example, like we have taken example like Delta Lake, how we'll perform the SQL merge or upsort operations from Delta table. We'll do import Delta table. This is the, then we'll create a variable, we'll given the path, then Delta table, it's a target dot merge. Okay, and then we'll source, what is the source you wanted to merge with, target ID equals to source ID, and based on that we are merging. Okay, so we'll go with the this is a simple just snapshot for that, and how we are doing in case of Hudi. So this is basically upsort operation, df.write.format Hudi, then options like Hudi customer, what are the table name we have, whatever the data source, or in which field basically wanted to do the record by field, and so whatever the options you wanted to do, we can do the upsort, append, and where you wanted to save, we can give the file path. So in case of Hudi we are doing like this, or in case of Apache Delta table we'll do like this. Okay, So when to use what, like if there is a machine learning pipeline, we'll go with the delta table. If there is incremental ingestion plus change data capture is there, we'll go with the Apache Hudi. If there is a only compatibility, if we'll talk about only the compatibility with the Spark, then we'll go with both. Okay, both are supported and both are compatible. So if multiple engines supported, so in case of Delta Lake, there is only one engine supported, Spark, or here Flink, Spark, Presto, all supported. Okay. In case of a streaming or batch pipeline, we'll go with both. Okay. If there is a high volume or real-time ingestions, we'll go with the Apache Hudi. Okay. So we will, based on the scenario or business use case, we will see which solution is useful for us for a storage layer, Delta Lake or Apache Hudi. Okay. So what we will summarize, like Delta Lake is like a transactional layer over Parquet focused on clean SQL style workflow, data versioning, and data science use cases. Okay, and Hudi is more likely if there is a change data capture or ingestion framework built on for real-time pipelines and more flexibility across compute engines. So if there is a multiple engines flexibility required, we'll go with the Hudi. If there's a data science project or data versioning or only SQL cleanup required, we'll go with the Delta Lake. Okay, so these are the uh, like summarized difference between them. Okay, now coming to the some other concept which we have discussed, we'll discuss in details here also. Okay, so what is a time travel basically? So time travel is nothing but time travel is a functionality where let you query previous version of your data as it is expected at a specified point of time or a version number. Okay, so suppose you purchase some product from last 20 days. Okay, and you wanted to query something like you wanted only the last month data to be updated. Okay, so show me something from the last 1 month. Okay, then how you will fetch that data? So these types of queries done by time travel. So how time travel basically work? So time travel is nothing but it will give the options to go previous in the time, go previous in like the history, and your fetch your data. Okay, based on some timestamp, like last 1 month, last 1 week, last 1 day, last 24 hours. So based on this time table, you can fetch the data. Okay. So how delta table works? So we already discussed like delta table. Delta Lake keep track of every change to a table using transactional log or called delta log. So apart from this file format, it will maintain a delta log also. Okay. So each write or update. So add a new JSON or Parquet log entry and assign to a version number like git commit. Okay. So each whenever there is a entry happen, it will assign a version number. Okay. Each write or any update happen. So use case like a rollback error, or if there is a suppose accidental deletion happened by some user, so how will roll back? If there is a audit required, historical tracking required, in this scenario we are using the delta lake, sorry, time table. If there is a rollback required, we are using the time table. If there is a debugging on the data pipeline required to see the previous data, we'll go with the time table. Okay, so we'll see with a simple example. Okay, so query data as it was at version 5. So at the version 5, like each commit it will maintain a version number. Okay, assign a version number. So suppose if you wanted to see what is the data at version number 5, so we'll go spark.date format delta option version as of 5 and load. So whatever the version it was there at number 5, it will showcase that. Okay, or you can use the timestamp also, spark.read format delta option timestamp. You will give the timestamp, like what timestamp you wanted to fetch the data, we can load the data. So based on these things, we can time travel and we can fetch the historical data to do the debugging purpose, to make the things, if you wanted something retrieve or any accidental deletions or any audit purpose, we can go back in the time and we can fetch the data. Okay, so delta storage looks like there is a delta log. So each commit or each update, each write happen, initial write will mention. After that, if there is update happen, delete happen. So for each particular transaction, it will maintain a log. Okay, and based on that log, it will basically fetch the data. Okay. Now, how Apache Hudi does it? So Hudi maintain a timeline of actions. So here it will maintain by timestamp or version number. in case of delta table, and in case of Apache Hudi, it's maintain a timeline of actions like commit, rollback, cleanup. Each commit gets a timestamp, instant timestamp, like any number. Okay, so use case like fetch all changes since last load, or support incremental pool for downstream system. So in case of how we are doing in case of Hudi, so a spark.read format equals to Hudi options incremental and option like begin in instant time. So what is the time, which timestamp we wanted to instant time? So we are giving the timestamp like this one, and we can load the data. So we will fetch similar to that how we are fetching in case of delta table. Okay, so Hudi does not have full SQL like time table by default, but yeah, it does support point in time query using being init instant and in the instant time. So begin init time like initial time, and in instant time means in last time. So based on this begin and int, it will fetch the data. Okay, point in time. Okay. Now coming to the schema evaluation. So what is schema evaluations? So schema evaluations is nothing but that means ability to change the structure of a table over time. Okay, like suppose there is a table, we have three data: id, name and age. Okay, and suppose new file you wanted to add the address. So this is the change in a schema of a table. So when there is a schema change happen, this is called schema evaluations. Okay, so schema evaluation means ability to change the structure of a table over time, like adding new column, change data type, renaming fields, or drop unused field. So these are the types of things which we are supporting in case of schema evaluations, useful in real world case where upstream data change over time. Okay, so till today we have the schema like something xyz. Now in future we wanted like some different column, so we'll add the new feature. Okay, so for that this is called schema evaluation. So in case of Delta Lake supports automatic schema evaluation with options like merge schema. Okay, so we have to remember that Delta Lake always support merge schema. Okay, so merge schema is supported by the Delta Lake. We'll see the use case like adding a column like customer status into existing table, or handle evolving schema ETL or streaming pipeline. Okay, so like suppose we have new data dot write format delta option merge schema true mode append save here. So we are saving the data based on this. Okay, merge schema, so automatically we are merging a schema. So if there is a automatic schema happen, so we'll do the automatic schema evaluation merge schema. So we don't have to manually, we have to change the schema. It will automatically evaluate the, you can add the schema. Okay, you can do by SQL also, like ultra table customer add column new column, and we will pass the string. So delta tech will validate a schema and block writes if there is a mismatch. So if there is a mismatch happen, delta table block that. Okay, in case of Apache Hudi, so Apache Hudi, how we are handling the schema evaluation. So Hudi supports schema evaluation by Avro schema. You must manage schema compatibility. So work well when you define the schema explicitly. So you have to define the schema explicitly. Useful in real-time ingestion from Kafka or Flink. So how we will do in case of your Hudi, the df dot write format Hudi options is true, id equals to 2, and that saved equals to 2. So Hudi allow additive change, so adding new column may need to do like Avro schema registry for validations and compatibility check. So you have to use the Avro schema registry in case of Hudi. Okay, so we will see the summary comparison in case of Delta Lake and Apache. Time table, full support, point in time per incremental load, version or timestamp, based on version timestamp. Schema evaluation automatic. So in case of Delta Lake, a schema evaluation happen automatically, like merge schema equals to true, if it will pass, it will handle automatically. But in case of Apache Hudi, manually we have to manually by Avro, or need more setup, like we can do the SQL command to do that. Like we can manage the manually schema here. Ease of use, you very user friendly, more complex with Avro or instant time. Okay, best for if there is audit, rollback or ML pipeline is required, we'll go with the Delta Lake. If there is a change data capture pipeline or real time ingestion happen, we'll go with the Apache Hudi. Okay, so that is the key difference between them. So in this video we covered what is Apache Hudi, what is Delta Lake, what is schema evaluation, what is time travel, with example like how we are doing that. Okay, and this is very useful at the time of a storage layer. Okay, thank you, thanks for watching.